Welcome to Homework Lib.
Friends, in the given circuit, the value of EMF is 48 volt, inductance is 8 Henry, capacitance is 20 microfarad, resistance R1 is 25 ohm and R2 is 5000 ohm. At t is equal to 0, S is closed. Let us start solving the part A. Applying the Kirchhoff's law. In the loop. First, in loop 1, that is EMF minus I1 R1 minus potential across inductor to be 0 and potential across inductor will be minus L di1 upon dt. Say this is equation 1. di1 upon dt can be written as E upon L exponential of minus R1t upon L. Putting in equation 1, we can write EMF minus I1 R1 minus L di1 upon dt to be 0, and solving above equation for I1 we will get E upon R1 1 minus exponential of R1 L upon T. In the largest loop, we will get E minus I2 R2 minus potential across capacitor to be 0. Potential across capacitor can be defined as charge on the plate upon its capacitance. Taking derivative of equation 2, we will write 0 minus R2 di2 upon dt minus 1 upon C dq2 upon dt. That must be 0. So from here you may write minus R2 di2 upon dt minus 1 upon C. I2 is equal to 0. Solving the equation, you will get Q2 is defined as integration of I2 dt for the limit 0 to t, and I2 having the value from above equation, you can write EMF upon R2 into exponential of T upon R2 into C dt On solving it and substituting the limit q2, you will get EMF into C1 minus exponential of minus T upon RC. In B part, from here I forget to write this equation I2 to be EMF upon R2 exponential of minus T upon R2 into C, and this is I1. Now second part, at t is equal to 0, I1 is equal to 0 and I2 is equal to E upon R2 exponential to the power 0. You will get 48 upon 5000. So it is to be 9.6 into 10 to the power minus 3 ampere. In C part, after long time at t is equal to infinity, I1 is equal to E upon R1 1 minus exponential of minus infinity. So it becomes E upon R1. E is 48, R1 is 25, so it is to be 1.92 ampere. I2, you will get E upon R2, so it is to be 0. In D part, we have to find the T for I1 to be equal to I2, equating both the equations. E upon R1 1 minus exponential of minus R1 T upon L is equal to E upon R2 exponential of T upon R2 into C. On simplifying, T can be written as, on simplifying this equation, T can be written as L R2C over L plus R2 square C. Substituting the value, L is given 8 Henry, R2 is given 5000, capacitance is 2 into 10 to the power minus 5, inductance is 8, R2 is 5000 square into C, that is 2 into 10 to the power minus 5, so it is to be 1.6 into 10 to the power minus 3 seconds. So after this time, both the current will be the same. In E part, at t is equal to 1.6 into 10 to the power minus 3 second, current I1 having the value E upon R1 1 minus exponential of minus R1T upon L. Substituting the value, EMF is 48, R1 is 25, 1 minus exponential R1 is 25, Time is 1.6 into 10 to the power minus 3 upon 8. So it is to be 9.4 into 10 to the power of minus 3 ampere. Now in the last part, we have to find the current. We have to find the time t half for I to be equal to I1 by 2, that is 1.9 by 2.96 ampere. So E upon R1, 1 minus exponential of R1t upon L to be 0.96. Substituting the value, this value is 1.92. 1 minus R1 is 25, L is 8 into T. So on solving it, T you will get 0.22 second. And this T we are calling T half. That's all. Thanks for watching it.